try to help out with the diff. But that's not what causes these. These will happen without the weight. Okay. In the Diamond Star then, let's talk about our compass turn real quick. How much bank angle do we use when we do instrument procedures?
Standard rate.
Standard rate. Why don't we use more? You're a little bit behind the radial, it's swinging through. Can you cheat it? What's going to happen every single time your students try to cheat it? Their nose is going to just drop. You go beyond standard rate and it requires more than just a little back pressure. So beyond standard rate does take quite a bit of back pressure, and every single time they exceed it, you'll know it because their altitude just went down. Okay? I love it when they do it over Fairfield because I'm only 500 feet above this stupid mountain. Okay? So, okay? So we have to use standard rate no matter what. So you miss your radial, too bad. Your standard rate, you've got to fix it. There is no cheating it. Don't let your students cheat it. Don't you cheat it. Okay, it's there for safety. How do I calculate a standard rate bank angle?
15% of your airspeed.
There we go, 15% of true airspeed. Okay, it's a good rule of thumb. How do we learned this last time, how do I calculate true airspeed?
2% for each 1,000 feet.
2% per 1,000 feet of my indicated. Okay, so let's take the Diamond Star. We normally cruise around at about 110 in cruise. So 110 knots equals how much true here at Provo?
Plus, like 18, 19, yeah,
120, right around, give or take. I like even numbers. I just round up. Okay, about 120, true. Really, really easy trick to do 15%. 10% of this, I just dropped the last number. 10% is 12. Well, half of 10% is 5%, right? Which would be 6. Well, 10% plus 5% would be 15%. 18. Really easy way to do 15%. Okay? So I would use an 18-degree bank angle for a normal standard rate turn. Unfortunately, I have a limitation on my compass. That compass, if I bank more than about 16 to 18 degrees, will stop working. Why?
They're erratic and unpredictable. About that.
Does it say that?
Is it? Yeah. That steeper angle banks an 18. Compass indications are right.
A compass was designed to measure what? If I bank beyond 18, not so horizontal anymore, a little bit hard to measure. And so they will either freeze, or they'll start flipping, or they just become unusable. Okay? Well, we have this awesome standby attitude indicator that we use, right? And it has a 10-degree mark and a 20-degree mark. I can hold halfway between the two, but I can't really decipher beyond that, whether I'm at 18 or 12 or... So we just make it easy. When doing a compass turn, the rule is you use a 15-degree bank or standard rate, whichever one is less. So in this situation, I'd use 15 because it's less. Let's turn the table. I'm in a climb out, 73 knots.
Sorry, this is only when you're doing compass turns, right?
Correct, we're still on compass turns. So this is all in reference to compass turns right now. Okay, so now I'm climbing out at 73 knots. What's my true airspeed? About 80. So really easy, I just drop it, divide it, 4, that's 12. Can you hold 12? I can hold 10, I can hold 15. You guys might be better pilots than I am. Well, let's make it easy. That's about a 10-degree bank then. You ever seen a student try to hold a bank angle? What we're trying to do is come up with very easy numbers to use. So here's the deal. If you're in a Diamond Star and you're in the white arc, you're going to use a 10-degree bank to do a compass turn. If you're out of the white arc, you're going to use 15 degrees. Why? That's the why. You need to make sure that your students know the why. Because they can take this information now and they can go jump in a faster airplane and do the same calculation and figure out the same sort of tricks. Once again, I'm in an emergency, I'm partial panel, I'm talking to ATC, they're telling me to turn to headings, and I'm sitting there going, okay, 15% of, that is not the time to be doing the math. So what we're doing is we're doing the math before, figuring out the tricks, and then that's what we're going to use for our emergency procedures. Any questions on that? You need to ask more questions. All right.
So this is just for the diamond stuff.
This is for any airplane that flies within this speed range.
Okay.
So if you go jump into Cessna 172, everything you've learned so far will work. So, okay, it's all based on speeds. Okay, so now we're going to do time turns. All right, I'm going to do a time turn. How many degrees per second standard rate? 3 degrees per second. So that would take me how many seconds to turn 10 degrees? So that's going to take me, oops, so we'll put 10 degrees over here. 10 degrees is going to take me 3 seconds. All right, you ready? Here we go. What was standard rate at 110?
18.
All right, here we go. Ready? 1, 2, 3. What did Grandma just do in the back? So is that acceptable for instrument flying? What's that?
Half standard.
All right, so time turns, we're going to use a half standard rate turn. Okay? The thing that I like to compare it to, everybody, has anybody not been on the airlines before? All right, everybody's been on the airlines. How do those airplanes move? Ever so slowly and just smooth. It's just a thing of beauty. That's IFR flying. That's how your students need to fly. There is no jerky movements, nothing. I'm off on my altitude. Do I jerk it down? No. Just a nice forward. Everything needs to be smooth, okay? So, time turn is going to be half standard rate. Well, let's make it really easy. Here's our rule of thumb then. If standard rate was 18, what's half of 18? 9? Oh, let's call that 10. Everybody agree? What's half of 10? Or half of 12? 6? 5 close enough? I've got a really easy set now. Time turns, in the arc, 5. Out, 10. Compass turn, 10 in the wide arc, 15 out of the wide arc. That's it. I've got something very simple to go back to when I'm now doing, when I'm in my emergency, so that I'm not panicking.
So you said 10 degrees in the arc?
No.
Out of the
Out.
arc? Okay.
Because the faster I go, the steeper the bank angle.
Right.
Okay? So, that means that half standard, this was standard rate, so half standard, 10 degrees would take 6 seconds. Which means that 5 degrees equals 3 seconds. Okay, going to make it really easy. A compass is divided into how many degree increments? 5 degrees. That means each line on a compass equals 3 seconds. So when we're doing a time turn, we make it very easy. I need to go from here to here. All I do is go 1, 2, 3, 4, 5, 6. 6 times 3 is 18. 18 seconds. Go. How long did that take me to decide what they're going to do? Not very long. Once again, that's the same exact thing. What happens is, if they're sitting there and they're going, okay, that's going to be 30 degrees. I'm doing standard rate. By this time, the examiner ATC is yelling at them, "Are you going to turn? What you doing?" Okay, and that's exactly what was actually happening on check rides. Was the examiner was like, "Yeah, I gave him instructions to turn," and it like took him 4 or 5 seconds, or not seconds, actually more than that, 30 seconds to decide where to turn. So it's all about having a very, very simple procedure. So this is what we're going to do when we fly. Is you guys will simply just count it. All right, I did a compass turn. How accurate are compass turns?
Not.
They're usually pretty good. They'll get you within 10 or 15 degrees, sometimes right on. Okay, depends on the day. No problem. I'm 15 degrees off.